Dear students, in this video we are going to learn about the concept of process synchronization. The contents of this video includes mutex locks, semaphores, types of the semaphores, how the semaphores are implemented, and what are all the problems that occur with the semaphore, that is deadlocks and starvation. Mutex lock. Every non-shareable resource in operating system is associated with a lock variable. This lock variable is also called as mutex variable. When a process wants to access the resource, it has to acquire the lock and then it should enter into the critical section. Then it should perform the access on that particular resource, then release the lock and come out of the critical section. This is the general procedure followed for accessing the non-shareable resources by making use of its associated locks. The locks can be called as a mutex lock or a mutex variable. So the implementation of these mutex locks are done by two functions. That is, one is by making use of the acquire function, another one is release function. These acquire and release functions are implemented with the help of hardware instructions, and these functions are atomic in nature. The meaning of atomic in nature is nothing but all the statements in the function, either they must execute completely or not. But this solution requires a busy waiting. The waiting at the while loop for the availability of the mutex variable is involving a busy waiting. Therefore, that busy waiting is called as a spin lock. Let us see how these acquire and release functions are implemented. Let available is nothing but a variable, mutex variable. The initial value of the available variable will be true. That means that the resource is available and is not held by any process. A process that wants to make use of this resource first acquire the lock, enter into the critical section, then release the lock and come out of the critical section and perform the operations in the remainder section. This is the execution sequence of a process making use of the mutex locks. So when it wants to acquire the lock, it calls the function acquire function. In this acquire function, the process will check the availability of the resource lock. If the resource lock is available, then it makes the availability of the resource as false and then it will enter into the critical section. If the resource is not available, that means if the lock variable is 0, the negation of 0 becomes 1 and while condition becomes true and the process will be blocked in this while loop. So the process will keep on checking for the availability of that lock variable until some other process makes the change in the lock variable, that is from 0 to 1. In that way, a busy waiting will be encountered by the process at this while loop. This waiting at the while loop is called as spin lock. Once the process completes its operation, it has to release the lock. In order to release the lock, it will call the function release function. In this release function, the process will change the lock variable, that is available variable, into true. That is, previously it is false, now it is changing into true. So therefore, once the lock variable value is released, then it will go to the remainder section of the process. In this way, acquire and release functions are used to perform the process synchronization. Semaphore is an integer variable. It is also a process synchronization tool that provides more sophisticated way of process synchronization. Semaphore makes use of two functions. One is wait function, another one is signal function. The wait function is also called as T function. Signal function is also called as V function. By making use of this wait function, the semaphore will acquire the lock and enter into the critical section. By making use of this signal function, the process releases the lock on the resource. Initially, a process wants to enter into the critical section. So first it will test the availability of the semaphore variable on that particular resource. If the value of the semaphore variable is 1, then the while loop will not be satisfied. The control will go to the next statement. The value of S will be changed from 1 to 0 and the process is permitted to enter into the critical section. So when the process come out of the critical section, it increments the value of the semaphore variable of that particular resource. So in that way, when a function wants to enter into the critical section, it decrements the value of the semaphore variable. Now, for example, the initial value of the semaphore is 0. That means the resource is not available. It is held by some other process. Now, a new process wants to enter into the critical section. It will check the value of the S variable in the while loop in order to acquire the lock on that particular resource. While S is less than or equal to 0, then the process will enter into the busy waiting state because the condition becomes true and while loop will repeat. Likewise, the process will be keep on waiting in the while loop for the availability of the semaphore variable S to change it to 1. So in this way, the value of the semaphore will block the process entry into the critical section. So as soon as some other process which is in the critical section come out of the critical section, then it increments the value of the semaphore. So 0 becomes 1. So therefore, when a process which is waiting for this S value, so this value will terminate for that process and that process will enter into the critical section. So therefore, immediately that process will change the value of S from 0 to 1 to 0. In that way, the semaphore variable value will be adjusted in order to control the entry or and exit of the processes into the critical section. Now let us examine how to synchronize two processes P1 and P2. Here the requirement for process P1 is the statement S must be executed before the statement S2 in the P2 process. So we want to control the execution flow of these two processes by making use of the semaphore functions, that is signal and wait function. So now the process P1 wants to execute the statement S1. The condition for P2 process is S1 should happen before S2. So therefore what we need to do is we can unconditionally execute the statement S1 without need to stop any process. So statement S1 in the process P1 gets executed. Now process P2 wants to execute the statement S2, but S2 should complete only after statement S1 is completed. So therefore, P2 process will be made to wait. In order to make the P2 process wait, the synchronization variable of this particular process will be marked as 0. That means initially the process synchronization variable is 0. So when it is 0, the wait function on 0 blocks the process P2. So it does not permit the process P2 to access the next statement because it falls into the spin lock and keep busy waiting for the termination of the while loop. So therefore process P2 will be blocked here because of the non-availability of the synchronization variable. Now P1 process is completing its execution, then it is changing the value of the synchronization variable by calling the function signal. So since signal is called on synchronization variable is implemented. So now when synchronization variable is turned from 0 to 1, the process P2 which is waiting on that particular synchronization variable, the while loop will terminate for that and process P2 come out of the while loop. Then it will go to the next statement in it, that is S2 statement. So therefore, after completing S1 only, S2 is guaranteed to execute. So in that way, we can control the execution sequence of the statements within the two or more number of processes by appropriately calling the wait and signal functions. Semaphores can be implemented in two ways. One is by using counting semaphore, another one is by making use of the binary semaphore. The binary semaphore indicates that the integer value of the semaphore variable should be 0 and 1, whereas the counting semaphore indicates that the value of the semaphore can be any range of integers. There is no restriction on the domain of that particular range. Semaphore implementation with busy wait. So whatever we have seen in the previous wait and signal function call, these are all the implementation of the binary semaphore, implementation of the semaphore with busy wait. Here the process will be blocked waiting in the while loop, checking for the availability of the semaphore variable. So that is the main problem with the implementation of the semaphore with the busy waiting function. So this busy waiting wastes lot of CPU cycles. Therefore, we need to implement the semaphore in an alternative way. So that is implementation of the semaphore with no busy wait. So here the busy wait is having a spin lock as the processes keep on spinning in the while loop for the lock. So in order to avoid this problem, we have another solution that is called implementation of the semaphore with no busy waiting. Every non-shareable resource in the operating system is associated with a semaphore variable. Processes which are waiting for that particular resource will be made to wait in the associated waiting queue. This waiting queue is a data structure. It has two items. One is a value, another one is a pointer to the next element in the list. So likewise, the queue is implemented in the form of a data structure. This data structure will maintain the list of processes waiting for that particular semaphore variable on that particular resource. These operations are implemented by using the block and wake-up function calls. The block function makes the process to enter into an appropriate waiting queue. A wake-up function removes one of the process from the waiting queue to start its execution. The implementation of this semaphore is done by making use of a linked list. The structure, each node is defined as a structure. The definition of the structure is like this. It has two variables. It has two elements. One is integer variable value. The next one is a pointer to the next element in the list. So this is the structure definition for the semaphore variable. Now let us see the implementation of wait function. Initially the semaphore variable value is 1. That means it indicates that no process is in the critical section and the semaphore value is 1 and the resource is available. Now when the process wants to enter into the critical section, then it will call the function wait. Example, process 1 is invoking the function wait function by passing this semaphore variable. The value of the semaphore variable is decremented, so therefore 1 becomes 0, and if the value of the semaphore variable is less than 0, that indicates that already some other process is in the critical section, so this process is to be added to the waiting list. But here in this case, the value of the semaphore variable is 0 only after decrementation, so therefore this condition fails. So that means the process will enter into the critical section because the wait is successful for process P1 because no process is in the critical section. So process P1 will enter into the critical section. Now process 2 wants to enter into the critical section. It calls the wait function by calling the semaphore variable. So here the value of the semaphore variable value is 0. So again decrementing the semaphore, it becomes -1. Since the value of the semaphore is less than 0, this process P2 is added to the queue. Process P2 is added to the queue. So likewise, if any other process comes, then that process also added into the queue. Like that, processes will be added to the list of waiting queue, and those processes will be made blocked. That means they will be in the blocked state. So in that way, the busy waiting is avoided here. The process will enter into the blocked state. Now, The process P1, after completing its execution, it will come out of the critical section and increment the semaphore variable value. So therefore, it called the signal function. So the signal function increment the semaphore variable value. So what happens? Semaphore variable value from -1, it becomes 0, and if it is 0 or less than 0, it indicates that there are some more processes are in the waiting queue. So therefore, one process from the waiting queue is removed and that process is made wake up. So that means this P2 process, which is in the waiting state and is in the blocked state in the waiting queue, so it is resumed and it will enter into the critical section. So in that way, the process will be removed from the waiting list and then will enter into the execution state. So likewise, this wait and signal function will help in controlling the process synchronization of more than two processes by making use of this linked list implementation of the semaphore. Here, busy waiting is also eliminated. Inappropriate use of this wait and signal functions makes the system enter into a deadlock and starvation state. Now let us see the inappropriate way of using these wait and signal functions by two processes. P0 and P1, there are two processes. They want to access the resources S and Q. S and Q are the semaphore variables of those resources. Initially, the process P0 is locking the first resource S. So initially, the value of S and Q are 1. That means no process is accessing that resource. So therefore, they are available. The values are 1 and 1 respectively. Now process P0 is acquiring the lock on the resource S. So it is calling the wait function on the S variable. Since wait on S is non-blocking because the value of S is 1, so S will be turned from 1 to 0 and process will go to the next statement. In parallel, another process P2 is acquiring the lock on the another variable, that is Q. So initially Q is available. The wait on Q variable does not block the process P1. So therefore, Q value is decremented and process will acquire the lock on that Q resource. So the first statement in P0 and first statement P1 both are successful. After the completion of these two statements, the value of S is 0, the value of Q is also 0. Now process P0 is trying to acquire the lock on Q. So therefore it is calling the wait function on Q. So calling the wait function on Q makes the process enter into the waiting state. So the while loop will be true for this function. The process will enter into a spin lock state here. So process is busy waiting for the termination of the while loop. So process is blocked now. Process P1, which is trying to access the resource S, so it will call the wait function on S. So therefore what happens, the value of S is 0. Applying the wait function on S makes the process P1 to enter into a blocked state. That means it will keep on checking the while loop, verifying the value of the S variable, and process P1 will enter into a blocked state. So in that way, P0 on waiting for Q variable, it will enter into the blocking state. P1 on waiting for S variable, it will also enter into the blocking state. So P0 will not terminate from the blocked state until P1 releases the lock on Q. P1 will not terminate from the blocked state until P0 releases the lock on the S. But without knowing each other, these two processes are waiting for each other to release the locks. So in that way, the process is now entered into a deadlock state because there is no progress happens after this statement in both the processes. Both the processes will be made to wait in the waiting queue, or they are made to wait in the while loop conditions. So in that way, the deadlock occurs if we do not make use of the statements in the appropriate way. So therefore, this indefinite blocking makes the process to enter into a starvation state, because a process may never be removed from the semaphore queue in which it is suspended. So this state is called as starvation. Priority inversion is also another problem that is encountered with this semaphore, because some low priority process holds a lock needed by the high priority process. So therefore, high priority process is made to wait for an unbounded amount of time or bounded amount of time. The solution for the priority inversion can be done with the help of priority inheritance protocol, priority ceiling protocol. Thank you for watching this video.